assembly language is the precursor to modern WebAssembly. Let's talk about it from first principles first. So, what is the assembly language? From a fundamental definition, it is a low-level symbolic representation of machine code, right? That's the technical way to think about it. It's instructions executed directly by a computer's processor, and these functions are a very thin abstraction layer above binary machine code, like ones and zeros. And these will give you the human-readable mnemonics that will correspond one-to-one with the processor operation. So it's essentially as low level as you can get in terms of talking to hardware. The core characteristics include ISA-Specificity, so you're directly mapping to a processor's instruction set architecture. You also can talk to the memory model, direct addressing of registers and memory locations and I/O ports. You also have the ability to do a execution paradigm, so sequential instruction execution with explicit flow control. Another core characteristic is the abstraction level. So this is the smallest possible abstraction from hardware, and it allows you to operate at a actual CPU execution step. So it's a pretty cool language to know, is to be able to directly talk to hardware. And then in terms of the critical components, we have the mnemonics first here. This is the symbolic representation of machine instructions like MOV, ADD, JMP, right? You're specifically doing these representations yourself. We also have operands. This would include the registers, the memory addresses, the immediate values. We also have directives. This would be assembler instructions like .data or .text that are not compiled to machine code. And then we have the labels. This would be symbolic references to memory location. Now let's think about how this will tie up into WebAssembly. Well, first up, if we look at WebAssembly or WASM or WASM, this represents a binary instruction format designed as a portable compilation target for high-level languages, making these deployment onto web platforms at a near native performance. So that's really the takeaway here, is that it's a slightly different abstraction, but it allows you to work at near native performance, which is a huge win. In terms of the architecture distinctions from traditional assembly, the abstraction layer is a virtual ISA. So it's not ISA, it's a virtual ISA designed for translation to multiple target architectures. The execution model is stack-based virtual machines with memory-safe sandbox. The memory paradigm is a linear memory model with explicit bounds checking. In terms of the type system, this is static typing with validation guarantees. Now, what about technical implementation? Well, the binary format is a compact binary encoding that's optimized for parsing efficiency. The text format, WAT, is S expression syntax for human-readable representation. The model system, in terms of what you're building, would be a self-contained execution unit with explicit imports and exports. And then in terms of the compilation pipeline, this is a high-level language with a LLVM that goes down to the WASM binary. So in terms of the relationship analysis here, it is a conceptual continuity. We have WebAssembly is going to extend those assembly principles, but going beyond them through virtualization and standardization, you still are able to preserve the assembly performance characteristics, but you have these additional features like the portability and the security guarantees. Now, in terms of the technical divergence here, the execution environment with assembly is hardware CPU. With WebAssembly, it's a virtual machine. In terms of memory safety, it's unconstrained memory access. In terms of WebAssembly, it's sandboxed linear memory. In terms of portable paradigms, WebAssembly is architecturally neutral, but assembly is very specific to the hardware, right? Because you're directly talking to the hardware. So in a nutshell here, WebAssembly is a evolution of the assembly language principles, but adapted to distributed computing environments. You still have the ability to do low-level performance and have cross-platform execution capabilities, but these are unavailable to assembly languages. So it is important to know about the history of assembly when you're diving into WebAssembly. And one of the ways that WebAssembly is able to get such incredible performance and also be able to build really interesting new technologies is leveraging what was done in the past. And this is really a track record with any kind of innovation. It's always incremental. It's always building on stuff that happened in the past, and WebAssembly is no different.